Hello, future scientists. I am Adam. Join me in this adventure where we will explore the physics of acceleration. So, what is acceleration? An object accelerates when its velocity changes over a time interval, or it is the rate of change of velocity. Question 1. Is Endo accelerating? Yes, her velocity is changing because her speed is increasing. Question 2. Is Isaac accelerating here? Yes, his velocity is changing because his speed is decreasing. Question 3. Are Endo and her friends accelerating? Yes, their velocity is changing because they're changing their direction. Question 4. Endo roller skates at an impressively fast speed of 5 meters per second in a straight path. Is Endo accelerating? No, because her speed and direction stay the same. There is no change in her velocity. Therefore, an object accelerates when it speeds up, slows down, or changes direction. So what is the formula for acceleration? We can write the formula for average acceleration as A equals delta V over delta T, which equals final velocity Vf minus initial velocity Vi divided by Tf minus Ti. Delta V here is the change in velocity in meter per second, and delta T is the time interval in seconds. The Vf and Vi are in meter per second, and Tf and Ti are the final and initial times in seconds. So therefore, the acceleration is in meter per second, since velocity is in meter per second and time is in seconds. So therefore, the unit for acceleration depends upon the velocity unit and the time unit. Question 5. Endo is biking. She accelerates from 3 meters per second to 9 meters per second in 4 seconds. Determine her acceleration. Using A equals delta V over delta T, we get 9 meters per second minus 3 meters per second divided by 4 seconds, which equals 1.5 meters per second. Question 6. Isaac's car accelerates from rest at a constant rate of 2 meters per second for a duration of 5 seconds. Determine the final velocity of the car. So acceleration equals Vf minus Vi divided by Tf minus Ti. The given data says A equals 2 meters per second, Vi equals 0 meters per second, since the car starts from rest. The delta T is 5 seconds. So plugging in the values, we see 2 meters per second equals Vf minus 0 divided by 5 seconds. So we get Vf equals 10 meters per second. Is acceleration scalar or vector? So A equals delta V over delta T. And velocity is a vector quantity, so delta V is also a vector quantity. And dividing this by the change in time gives acceleration, which is also a vector quantity. Acceleration of an object tells us not only the magnitude of the velocity change, but also the direction. Positive versus negative acceleration. What is positive acceleration? Case 1. Endo has a positive acceleration here since she is speeding up and moving in a positive forward direction to the park from her home. Case 2. Endo has a positive acceleration here as well since she is slowing down and moving in a negative reverse direction to her home from the park. Case 3. Isaac has a negative acceleration here since he is slowing down and moving in a positive forward direction to the store from his home. Case 4. Isaac has a negative acceleration here as well since he's speeding up and moving in a negative reverse direction to his home from the store. Uniform acceleration and non-uniform acceleration. Uniform acceleration means Isaac's velocity changes by the same amount for each second. Here is a sample data table for uniform acceleration. The change in velocity here is 5 meters per second for each second. So what is non-uniform acceleration? Isaac's non-uniform acceleration means his velocity changes are not equal for each second. Here is a sample data table for non-uniform acceleration. The delta V here varies for each second. What causes acceleration? According to Newton's second law of motion, a net force acting on an object causes it to accelerate. This acceleration is directly proportional to the net force acting on the object and inversely proportional to its mass. Mathematically, this relationship is expressed as F equals ma, where F is the net force in newtons, m is the mass of the object in kilograms, and a is its acceleration in meter per second per second. Challenge questions. Question 7. Endo is riding a bicycle with a mass of 10 kg. She exerts a force of 50 Newton on the pedals and encounters an opposing force due to air resistance and friction of 50 newtons. Determine the acceleration of the bicycle. The net force here equals the forward 50 newtons minus the friction force 50 newtons, which equals 0 newtons. Acceleration equals net force over mass, so which means here the acceleration equals 0 meter per second. Since the bicycle is already in motion, it continues to stay in motion at a constant velocity. Question 8. Isaac kicks a soccer ball with a mass of 0.4 kg with a force of 12 newtons. Calculate the acceleration of the soccer ball. So here the mass equals 0.4 kg and the net force is 12 newtons. A equals net force over mass, so plugging in the values we get acceleration is 30 meter per second. Question 9. A car of mass 800 kilograms experiences an acceleration of 2.5 meter per second in the forward direction. If the friction force against the car is 1000 newtons, how much is the thrust force of the car? So the given data is the mass is 800 kilogram, acceleration is 2.5 meter per second, and the friction force is 1000 newtons. So net force is mass times acceleration. So we can figure out the net force, which is 800 kilogram times 2.5 meter per second, and that equals 2000 newtons. Net force is equal to the forward thrust force minus the reverse friction force. So 2000 newtons equals thrust force minus 1000 newtons. So we get thrust force equals 3000 newtons in the forward direction. Question 10. A rocket is launched vertically. The rocket's engines produce an upward force of 12,000 newtons. However, air resistance exerts a downward force of 2,000 newtons. If the acceleration of the rocket is 20 meter per second, calculate the rocket's mass. Given data is the upward force 12,000 newtons and the downward force 2,000 newtons and the acceleration, which is 20 meter per second. So the net force is the upward force minus the downward force. So that equals 10,000 newtons. Net force equals mass times acceleration. Mass is net force over acceleration. So we get 10,000 newtons divided by 20 meter per second gives you 500 kilograms for the mass of the rocket. There you have it, the physics of acceleration, which is a thrilling journey into the fundamental principles that govern motion. Happy learning. Thank you.